Hi there and welcome back to the channel. I'm Brian and well, today board 001 is back on the bench. Yep, heat issues. It's getting a little bit warmer here in Texas this weekend. There was a problem, if you'll remember, right across this side, the hot side of the board. So it was overheating and this didn't have that Noctua grease treatment. So it just failed, right? It got hot and it said, I quit. So let's look at the tester real quick. Uh-oh. More damage than I thought. Bummer. We lost the chip. All right, well, since I'm going to go ahead and re-grease this on the hot side, let me get the heat sinks off, and then we'll do some jumping and figure out what domain the problem is in. Heat sinks are taken off the board. I did lose 2 heatsink nuts. I will take care of those after we get the board working again. It looks like this board's going to go into an alcohol bath at this point. It'll be real easy to fix those heatsink nuts while I've got the board out. Let's go ahead and run the test again. I have increased the voltage. If you'll notice, is now up to 18.7. All right, I like running the voltage a little bit higher when I'm doing jumps, but not the full 21 volts. We're going to put the test leads. I've got my jump leads right there. See, they're together. I'm going to put 1 point on the RO test point, and I'm going to use the other one on the 1.8 volt right there. Okay, good. I know I got 30. Now, in case you were wondering how to find that 1.8 volt, let me show you a chip. So if you see a chip diagram there, so you got pin 1 is in the top left-hand side of the chip. When it's on the board, you find that circle, right? And you know that's pin 1. Well, at the other end of the chip is pin 16. That's your 1.8 volt. On that same end of the chip, to where you see pin 17, that's the other place you can find 1.8 volts. So if you'll just trace on the board, you can find where there are capacitors. Just touch right there at the solder point. That's an easy place to get your 1.8 volts. Just make sure you're getting it from the right domain, the domain where you're testing the RO. So in this case, I'm testing the RO between 30 and 31. So I'm going to go ahead and grab the 1.8 volt off of the 31 chip. All right, let's go on. We'll go to 40. 40 is good. Okay, so between 40 and 50, there's a problem. So what I'm going to do, I'm going to jump to the other end of the board. I'm going to do the same thing. I'm going to grab the RO and the 1.8 volt. Okay, so I know that 45 is good. So let's find out. Ooh, that's kind of sticky there. Okay, let's see if 46 is good. 46 is good. I can leave my test probe on the 1.8 and I can just keep going down the ROs. Oh. Okay, 46 is good. 47's good. 48's good. Uh-oh. 48's good. 49's no good. All right. So there we go. Now we know what I've got to take. Oh, that's a bummer. That's a chip I replaced. Let's get under the microscope and find out if we can see anything of interest. Okay, well, I was hoping that I'd get lucky and find a solder ball or something. It does not look that way. Resistors all look okay. So I guess we'll take the chip off and replace it. Hold on just a second. I want to show you something. Let's see what that looks like on the camera. Oh yeah, there we go. Perfect. So I made this note the other day that I had already, it says I've already replaced chips 47 through 50. And this is why this is of interest to me. All of these chips were 0 Once you got down past 18.7, that whole domain would drop out. So maybe it was because of chip 49, but it could also be because of chip 46. So before I replace 49, we're going to replace 49, but I also want to go ahead and check. I think 48's okay because it gave me 3, so it at least gave me a value. I think 50 may be bad because it was affected by 49, but 46 and 47 being 0, I want to measure the diode values on these chips before we just replace chip 49. So let's do that. If you don't know how to do that, let me get over to the test screen there. And I've got the, if you'll notice, right up the top, you've got the meter. I'm going to set my meter into diode mode, and I'm going to put a sharp pointy probe on my negative. Now, the way this works is you simply go through, you put the positive probe on the top of the chip, and you're just going to check the test points. And ideally, you want 1.2, 1.1. Okay, so let me tell you which ones. So BI should be 1.2 on the S17 Plus. The RSTI, that should be 1.1-ish. If it's 1.2, you got a problem. The RO should be 0.4 something. Again, if it's in 0.5, you have a problem. Other than these next two, CI and clock, they should be 1.2. If they're 1.3, probably have a problem. Okay, so that's all good. Go. Good, good, good. Let's check 47. Oh, look at that. 47's high. That should be 1.2. Okay, now it is. But it's real close on the edge. Should be 1.1. It is 0.4. Yep. 1.2. 1.29. Okay, so 47's a little iffy. Let me check on the back side of the signal flow. Remember that order. If I'm going, I'll put this up on the screen. BI, RST, and the RO, CI, and clock. And with your meter, if you're using a different meter, I'm using this O1. Mine may be a little bit higher or a little bit lower than yours. Ah, look at that. Oh my gosh. Okay, so 47 and 48 are definitely suspect chips. Yeah. Check it on the backside. Yeah, we know 49's bad, so but I'm gonna look at it anyway. Let's see if we can find any values that are out of whack. Okay, all the values look good. I mean, so you would think that would be an okay chip, but not quite. All right, I'm gonna go ahead, since 47 and 48 seem to be a little suspect. I've got it apart. Let's go ahead and yank them off. All right, we're back. I think the chips have cooled off. 47, 48, and 49 have been replaced. Let's test it and see what we get. There we go. 40 or 65 chips. I really expected when we replaced 49 we'd get that, but also wanted to replace those other two because they were a little suspect. Let's check our heat readings. Temperatures look good. All right, so let me go ahead and fix the two spots that we lost. Actually, we lost 3, I think, because lost this nut here, we lost this nut here, and we lost a nut down here. So that's 3 nuts. If you want to see the video of how I actually put those nuts on, I'll put a link to the video up in the top right of this video that shows you. You can see in that one where it goes better. It's a better way of installing than what I'm going to do here. So let me get those nuts soldered on, and we'll get this in an alcohol bath, and then we'll put thermal paste on, and we'll get this back in a miner. Okay, so the board's had time to dry. Just clip the power back on to the board, and let's find out if the board passed after its nice little trip to the alcohol bath. There we go. 65 chips, very good. Quick check of the temperatures. Looks good to me. So I'm gonna go ahead and put the heatsink grease on. The plan is I'm gonna put the Noctua heat thermal paste on these 2 hot rows, and then these 3 cooler rows here will get the standard high 510 thermal paste. So let's do that. Okay, so there you go. It passed its test. The temp sensors look good. This board is assembled and ready to get back in the miner. So let me put it in the miner, and we'll see how the results turn out for this board. Hopefully, this will be the last time we see board 001 until my new thermal paste comes in, which is rated for the S17 series. So that's going to really be good, and I'll use that thermal paste throughout the board. Let's get this thing into the miner and get it back to work. Woo, look at that. That is some sweet news right there, folks. Let me point some stuff out that's kind of important. First of all, if you look at the temp for the chips, you'll notice that they're 73, 71, 71, 77. Now, as a reference, let me show you the video from the other day. I'll just flip over to YouTube. And you can see right there that board 1 temps were 67, 74, 68, 83. So that chip where temp sense 4 is, which is 51, it's just a hot chip. But notice the difference. So our cool side of the board was 67 the other day. Our cool side of the board today is 72. It's hotter today than it was the other day when I was doing this. So look at the overall difference. We have a 6-degree difference from the coolest part of the board to the hottest part of the board versus the other day when we had a 16-degree difference in temperature. So quite an improvement using the Noctua and high 510 solution together. All right. So there we go. We've got the board back in action. The other cool part is we are now running 18.6 versus the 18.8 that it was running the other day. And look at this. Replacing chips 47, 48, and 49. That was the winning idea because, as you can see now, I've got just about all green chips. That one yellow chip up in the first corner, I'm not going to worry about that. That's a fine chip for now. I will probably replace that chip 51. Even though it looks green, I'll probably replace it because of the hot temperature that it's running at. So for now, board 001 is back in action. Hopefully it'll stay in action. This whole repair took about 2 hours, so it was a really win-win solution for me today. Thanks for watching. If you like this video, give it a thumbs up. If you want to be notified of more videos like this, be sure to hit that subscribe button. And hey, check out one of these other videos to see what else is going on the channel.